Very warm greetings everyone. Today I'm presenting our work on fact-aware multitask learning for text coherence modeling. This work has been done in collaboration with Tushar Abhishek, Daksh Rawat, Professor Manish Gupta, and Professor Vasudev Verma. So let's dive in. What is text coherence? Coherence is an important aspect of text quality and is crucial for its readability. It captures how well the sentences are connected and how well the document is organized. Coherent documents have a clear topic transition that are discussed throughout the text with a smooth flow of concept, typically in increasing order of complexity. It is also essential for the output from text generation systems like summarization, question answering, machine translation, and question generation. Following are the previous work. In this work, we propose three transformer-based architecture. Vanilla transformer, second is fact-aware transformer, third is fact-aware multitask transformer. We use Roberta for short text sequence and Longformer for very long text sequence. The first approach is vanilla transformer, a trivial approach for training transformer-based architecture on downstream coherence tasks is to simply fine-tune the pre-trained model. We use task-specific head for different tasks. It can be classification or regression task. The second approach is fact-aware transformer. We hypothesize the transition of the fact associated with the entities across the sentence could help better capture the essence of text coherence. Our approach is to fuse the document level information with factual information. For this, we extract fact for a given input string using open information extraction system called MinIce system and use this as additional input to the model. Fact are ordered tuple consisting of subject, verb, and object. This architecture has three different modules. First is document encoder. On the right hand side of your screen you can see the architecture overview. So the first is document encoder, second is fact encoder, and third is fact aware document encoder. So the job of document encoder is to encode the text directly. The job of the fact encoder is to encode each of the fact individually, and the job of the fact-aware document encoder is to fuse the representation coming from the document encoder and the representation coming from fact encoder and give us a final document representation that can be used in downstream tasks. We enhance previous architecture by adding a secondary task of natural language inference. Natural language inference is a task of determining whether a hypothesis is correct, false, or undetermined given a premise. We train a model in multitask setting where the primary task is a downstream text coherence task and the secondary task is natural language inference task. In the slide, we present the algorithm to train the multitask learning over our model. First, we concatenate the two datasets to create a global dataset. Then we shuffle this dataset and iterate over batches. Within each batch, we use task identifier to accumulate the loss for the respective task, and finally calculate the loss by adding these two. Moving on to text coherence evaluation task. There are three different text coherence evaluation tasks. First being sentence ordering. It consists of positive sample where every document is assumed to be coherent, and negative sample where 20 different random permutation of the original sentence in the original document is taken. The task is to rank the original document higher than the permuted one. Second task is three-way classification. The task is to classify a document to one of the three levels, high, medium, and low. The third task is of essay score prediction. The task is to assign a score to given essay. So the sentence ordering and three-way classification are the classification task, and essay score prediction is a regression task. Moving on to the dataset. The first dataset that we encounter is Wall Street Journal or WSJ dataset, which contains high-quality long article without any constraint on style. It was used for sentence ordering tasks, and following are the statistics for WSJ dataset. Moving on to the second dataset, which is Grammarly Corpus of Discourse Coherence or GCDC dataset. The GCDC dataset contains email and review written in with the varying degree of proficiency and care. In contrast to WSJ, the GCDC dataset contains writing from non-professional writers in everyday's context. The dataset consists text from 4 domains: Yahoo Online Forum post, email from Hillary Clinton's office, email from Enron and Yelp business reviews. Each document is annotated with the coherence labels: high, medium, and low. Following are the statistics for the GCDC dataset. Another thing to note here is the average number of word count in GCDC dataset is quite less when compared to WSG dataset. Moving to the last dataset, which is Automated Student Assessment Prize, or ASAP dataset, which is taken from a Kaggle competition. The essays are categorized in 8 prompts based on essay topic and genre. On the right hand side of the screen, you can see the statistic related to the ASAP dataset. This dataset is used for essay score prediction, which is a regression task. Following are the experimental setup. The reported result are mean of 10 runs with different random seed. In multitask learning setting, we use categorical cross-entropy laws for secondary tasks of natural language inference. For sentence ordering tasks, we apply Siamese network with each of our proposed architecture. At the bottom of the slide, you can see the Siamese network architecture. Moving on to the result. This table shows result on the sentence ordering task on Wall Street Journal dataset. We report pairwise ranking accuracy. We observe that all the proposed approaches perform better than the previous approaches. The both approaches that encode facts are better than vanilla transformer. It can be attributed to the reasoning that the transition of the fact is essential for text coherence detection. This table shows result on three-way classification on GCDC tasks. We report accuracy in this table. We also observe that fact-aware multitask learning model is better than fact-aware model, which signifies that addition of secondary tasks has improved the underlying downstream task of detecting the text coherence. Another thing to mention is classifying document of medium level coherence is hard, as the number of sample is quite less in this category. Moving on to automated essay scoring results. This table shows result on automated essay score prediction, where we report quadratic weighted kappa score. For this task, we compare vanilla long former architecture with a long former enhanced with a coherence vector from fact-aware multitask learning approach. We concatenated the CLS token representation of long former with the coherence vector obtained from the fine-tuned WSJ sentence ordering task. As you can see at the bottom of the table, we have a vanilla long former which is just fine-tuned over automated essay scoring dataset. And we have a long former which is augmented by the coherence vector from fact-aware multitask transformers. And it is performing on an average better than the simple vanilla long former approach. Similar to the previous study, we examined the coherence score assigned to the artificial miniature discourse to understand the model performance. So the first qualitative analysis is a lexical coherence. The example suggests that both the model handle lexical coherence correctly and favors first sentence over the other sentence. So in our example, the first sentence is Mary ate some apple, she likes apple. In both the sentences, we talk about apple. But if we take second sentence, we have Mary ate some apple and she likes pears. In the second sentence, apple is not being referred. Instead, pears is being referred. So in this case, the coherence score should be relatively lower than the first sentence. And same goes with the third sentence as well. But in the third sentence, we have an entity which is entirely different from the previous entity. In the second sentence, at least we are comparing a fruit with another fruit. But in the third sentence, we are comparing a fruit with, let's say, or we are referring a fruit with another category, which is a place. So the third sentence should be comparatively scored less uh, when compared with the other sentences, first and second. So both the vanilla transformer and our fact-aware multitask transformer are able to distinguish or give scores which are lower for the last sentence and which is higher for the first sentence, which is most coherent in terms of lexical coherence. Same goes with the second example as well. Moving on to the qualitative analysis, which is a temporal order. So both model handles temporal ordering quite well. The third qualitative analysis is centering or referential coherence. So here, the entity that is referred in the first sentence should be referred as a central entity in the remaining sentences. So this was the first example that we have introduced in the first slide. So as we can see, like in the first example, John is the central entity and he is being referred in all the other sentences at the start of the sentence. But in the second example, we can see John is the central entity in the first sentence. But in the second sentence, the store becomes a central entity. Like it was a store John had frequented for many years. So it is a central entity in the second sentence. So this whole paragraph should be given less coherence score uh, when compared to the first sentence. So we ran a vanilla model and our fact-aware multitask transform model and found out that vanilla model was given the second paragraph greater coherence score, which is wrong. But our fact-aware multitask learning transformer is able to distinguish, and it's basically allocate higher score to the first paragraph and lower score to the second paragraph, which is true in terms of centering or referential coherence. Key takeaways. In this work, we propose a fact-aware multitask learning model for text coherence assessment. We observed that fact-aware coherence model performed better than previous and vanilla transformer approaches. We observed that fact-aware approaches outperform existing model on synthetic data like WSG as well as real-world data such as GCTC dataset, and also improves upon essay scoring. In future, we plan to extend this work to evaluate the text coherence in open domain setting. Thank you for listening and have a great day.